On a quiet night, look up at the sky. You'll see tiny points of light, but between those stars lies an enormous darkness. And the strange question is, if the universe contains hundreds of billions of galaxies and each galaxy contains hundreds of billions of stars, then why isn't the entire sky glowing? Why doesn't night turn into permanent daylight? This question puzzled scientists for centuries, until it became one of the most famous mysteries in astronomy. It's known as Olbers Paradox. But the surprising part is this: the darkness of the sky is not ordinary at all. It is actually deep evidence that the universe had a beginning, that it is expanding, and that we live inside a dynamic and incredibly strange cosmos. Now imagine something simple. If the universe were infinite and filled with stars everywhere, then every line of sight in the sky should eventually end on the surface of a star. It's like standing in an endless forest. No matter where you look, you would always see a tree. Using the same logic, in, inf- in an infinite universe full of stars, the entire night sky should shine brightly, almost like the surface of the sun. But but that doesn't happen. The sky is dark, and that is where the paradox begins. Back in the 19th century, astronomers tried to understand this mystery. One of the most famous people associated with it was the German astronomer Heinrich Wilhelm Olbers. But the truth is, the idea is much older than that. Even Johannes Kepler thought about this question as early as the 17th century. The question sounded simple, but it was revolutionary. If the universe was eternal and static, then why does darkness exist at all? At the time, many people believed the universe had existed forever, no beginning, no end, but the darkness of the night sky was telling a completely different story. It was saying something about that picture is wrong. To understand the answer, we first need to understand something extremely important. Light is not instant. Light takes time to travel. Its speed is enormous, about 300,000 kilometers per second. But even at that unbelievable speed, cosmic distances are vastly larger. Light from the Sun takes about 8 minutes to reach Earth. Light from the nearest star beyond the Sun takes more than 4 years. But what about stars billions of light years away? That's where the real story begins. The universe is not eternal. According to the best modern measurements, the universe is about 13.8 billion years old. That means there is a limit to how far light could have traveled since the beginning of time. So, light coming from places farther away than that has simply not reached us yet. In other words, we cannot see all the stars in the universe. We can only see the stars whose light had enough time to arrive here. Imagine a gigantic bubble surrounding Earth. Everything inside that bubble has had time for its light to reach us. Everything outside of it remains invisible to us. This is known as the observable universe. We don't see the entire universe, we only see the observable universe. And that is why some parts of the sky appear dark, because the light that should fill those regions is still traveling toward us. But this is not the end of the story. Even the light that reaches us from distant galaxies faces another problem. The universe is expanding. Yes, space itself is stretching constantly. This discovery completely changed our understanding of reality. Big Bang. As the universe expands, the waves of light expand too. This creates something called redshift. Redshift. The farther galaxies move away from us, the more their light stretches. At first, the light is visible, then it shifts into infrared and eventually into microwave lengths, invisible to the human eye, which means something incredible. A huge portion of the universe's light is actually there, but our eyes simply cannot detect it. And here comes the truly mind blowing part. Space space is not completely dark at all. In fact, the universe is filled with ancient light. The oldest light is in existence. It is known as the cosmic microwave background. This radiation is the leftover glow from the earliest moments after the Big Bang. It exists in every direction of the sky, but because the universe has expanded for billions of years, its wavelengths stretched as well until they became microwaves. That's why we cannot see it with our eyes. In 1965, scientists Arno Penzias and Robert Wilson discovered this radiation almost by accident, and it became one of the strongest pieces of evidence supporting the Big Bang model. Because the universe still carries the echo of its birth. But wait, there is another strange point. Even if we ignored the expansion of the universe, Stars themselves are not eternal. Stars are born. They live for millions of, or billions of years, and eventually they die. Even our own sun will not last forever. Sun. In about 5 billion years, it will begin transforming into a red giant, and eventually it will end as a white dwarf. In the unimaginably distant future, most stars in the universe will disappear, leaving behind a cold and dark cosmos filled with white dwarfs, black holes, and stellar remnants. Black hole. So, the darkness of the sky is not simply the absence of light, it is a cosmic message, a message telling us the universe had a beginning. Light takes time to travel, the universe is expanding, and our eyes can only see a tiny fraction of reality. When you look at the night sky, you are not looking at emptiness, you are looking into a universe 13.8 billion years old, at light that has traveled for billions of years, and at regions whose light still has not arrived. In every dark patch of the sky, there may be entire galaxies whose light is still on its way to Earth. And perhaps that is the most beautiful thing about the universe. Darkness itself became scientific evidence, evidence that the universe is not static or eternal, but has a story, a beginning, and a history. And the next time you look up at the sky, the night sky, remember that the darkness you see is not emptiness. It is a window into the deepest mysteries of the cosmos, and every point of light above you is a message sent from the distant past, and somewhere beyond those cosmic shadows, there may still be wonders whose light has not yet reached us.